The Retrievable Process Module, or RPM, is an interchangeable module with a standardized interface between itself and the tree. The design of the RPM allows for multiple configurations, including flow meters, chokes, sampling, sensors, and sand detectors. The RPM for the Deka project houses a wet gas flow meter, or Wgfm. The Universal Multipurpose Running Tool, or UMPRT, is used to install and retrieve several different subsea components, including SCMs, chokes, or in this case, the RPM. The initial setup on deck includes ensuring all of the controls on the UMPRT are set in the vertical position. To prepare subsea, the top and side hatches of the tree fishing protection structure have to be removed, along with the dropped object protection cover on top of the RPM mounting base. Before the RPM can be disconnected from the hub and removed, the production flow path must be isolated. The production wing valve, PWV, must be shut from the tree side, and the flowline isolation valve, FLIV, must be shut from the flow base side. The ROV must remove the long-term cover from the electrical flying lead parking position on the flow base. And then remove the EFL from the wet gas flow meter position on the RPM. The EFL is then placed in the parking position on the flow base. To release the RPM from the RPM mounting base, the ROV inserts the low torque tool into the ROV bucket and turns the drive anti-clockwise to release the clamp. This in turn unlocks the RPM. When unlocked, the visual position indicator is extended, showing a yellow shaft. The multipurpose running tool is lowered subsea. The ROV aids the final descent before making contact with the RPM mounting base. To show the tool has fully landed on the structure, the Tool Landed LED is illuminated. The ROV moves to the top connection of the MPRT to set the weak link system. The weak link system is in place to allow for an emergency release if there is a situation due to severe weather or snagging. If this occurs, the shear pins inside will shear and release the line from the MPRT. The ROV provides hydraulic power to the MPRT via the hot stab receptacle HS1. To lock the MPRT to the structure, the ROV rotates the tool valve anti-clockwise to lock until the tool locked LED is illuminated. It then returns the valve to the center position. The ROV will then move to the latch valve and rotate it clockwise to open until the latch O LED is illuminated. It will then return the valve to the center position. This keeps the latch open so the tool can interact with the lift mandrel of the RPM. To ensure the MPRT connection is in the lowest position as the RPM is locked to the RPM MB, the ROV rotates the SCM valve anti-clockwise to the lock position. The mandrel LED is not illuminated at this point as there is no RPM in place. The valve is returned to the center position. The ROV then moves to the beam valve and rotates it anti-clockwise to down. The internal lift beam of the MPRT moves down until it comes into contact with the lift mandrel of the RPM and is fully engaged. At this point, the mandrel LED is illuminated and the valve is returned to the center position. The RPM is then locked to the MPRT as the ROV rotates the latch valve anti-clockwise until the latch C LED is illuminated. The valve is then returned to the center position. The ROV will then move to the SCM valve and rotate it clockwise to unlock. This lifts the RPM slightly and separates it from the hub. The mandrel LED goes out and the valve is returned to its center position. Once the RPM is separated from the hub, the ROV rotates the beam valve clockwise to up to lift the RPM from the mounting base. The RPM is lifted until fully inside the MPRT payload bay. The valve is then returned to its center position and the ROV visually checks that the RPM is inside the MPRT. With the RPM inside the MPRT, it is now ready for retrieval. First, the tool is unlocked from the RPM MB as the ROV rotates the tool valve clockwise to unlock and the tool locked LED goes out. The valve is returned to the center position and the function lines are vented before the ROV removes its hot stab. Once the hot stab is removed, the ROV sets the weak link system on top of the MPRT to the safe lift setting, and the MPRT can now be retrieved. The MPRT with RPM inside is then lifted back to the surface. With the RPM in the exchange skid resting on the seal changeout supports, the 4 screws and 2 retainer quadrants can be removed, allowing for the changeout of the hub seal. Before reinstallation of the seal, the area of the sealing faces should be checked to ensure they are clean and bright and free from any mechanical damage. The new hub seal can then be fitted in position as the 2 retainer quadrants are held in place by 4 countersunk screws. Care must be taken to ensure that the seal retainer quadrants do not obstruct the back seat test port which exits on the mating surface. The final step of the single seal changeout is to replace the outer O-ring and ensure it is seated in its groove correctly. The process is then repeated to replace the second hub seal ring. The multipurpose running tool with RPM is lowered sub-sea. The ROV aids the final descent before making contact with the RPM MB. To show the tool has fully landed on the structure, the tool landed LED is illuminated. The ROV moves to the top connection of the MPRT to set the weak link system. The weak link system is in place to allow for an emergency release if there is a situation due to severe weather or snagging. If this occurs, the shear pins inside will shear and release the line from the MPRT. The ROV provides hydraulic power to the MPRT via the hot stab receptacle HS1. To lock the MPRT to the structure, The ROV rotates the tool valve anti-clockwise to lock until the tool locked LED is illuminated. It then returns the valve to the center position. The ROV then moves to the beam valve and rotates it anti-clockwise to down. The internal lift beam of the MPRT moves the RPM down until the component is fully installed. At this point, the mandrel LED is illuminated as the RPM has landed. The valve is returned to the center position. The RPM is now installed in the RPM mounting base, and the ROV rotates the latch valve anti-clockwise until the latch O LED is illuminated and the mandrel and latch C LEDs go out. The valve is then returned to the center position. Once the RPM is unlatched from the MPRT, the ROV rotates the beam valve clockwise to up to lift the beam. The beam is raised until fully inside the MPRT. The valve is then returned to its center position, and the ROV visually checks the RPM within the RPM-MB. With the RPM inside the RPM-MB, the MPRT is now ready for retrieval. First, the tool is unlocked from the RPM-MB as the ROV rotates the tool valve clockwise to unlock, and the tool locked LED goes out. The valve is returned to the center position, and the function lines are vented before the ROV removes its hot stab. Once the hot stab is removed, the ROV sets the weak link system on the top of the MPRT to the safe lift setting, and the MPRT can now be retrieved. The RPM has been installed in the correct position using the MPRT. It now must be locked into position by making up the clamp connection. The ROV uses a torque tool and inserts it into the torque receptacle. The tool then rotates the drive clockwise 28 turns and at a torque of 1900 Newton meters, closing the clamp and making up the connection. To ensure the clamp is locked, the ROV checks the visual position indicator above the receptacle and confirms it is in the shut position. To ensure both seals are correctly seated, back seat seal tests are performed. The ROV will remove the dummy hot stab from the receptacle and place it in the parking position above. The ROV will then take its hot stab and insert it into the receptacle. To test the first seal, the hot stab will use port B and port A will be vented. The pressure is increased from 0 to 1500 psi, at which point the pressure is held for 5 minutes, and pressure and timing is recorded. Upon completion of a successful test, the pressure is gradually vented to 0. This process is then repeated with the ports in the opposite configuration for the second seal, before removing the hot stab and replacing the dummy hot stab in the receptacle. Once the backseat seal tests are complete, the EFL can be connected. The ROV removes the long-term cover from the Wgfm receptacle and stores it. It then moves to the EFL on the floor-based parking position and connects this to the Wgfm position on the RPM. After connecting the EFL and successfully completing the backseat seal tests, the Christmas tree's SCM is powered up to ensure that there is communication to and from the wet gas flow meter within the RPM. After successful communication with the wet gas flow meter, the RPM is fully installed. The last steps are to add the cover and hatches to ensure it will not get damaged. The dropped object cover is lowered into position first and locked down. Following this, the fishing protection structure hatches are installed and all rigging is retrieved to the surface.